Hello once again, guys. Welcome to our YouTube channel. Welcome to Additional Mathematics plus Maths. Okay, we are going to discuss a lesson still in differentiation, but it's a little bit of application of the ideas that we have learned about differentiation, and we will apply it with what you call as rates of change. Okay, when we say change, if there is change that is happening, basically, to define change in simple terms, there will always be time. Okay? In other words, changes happen with respect to time. Because if there is no time, there will be no changes. Okay? Of course, if there's no time, then it's stable. Nothing will change. Okay? So when we talk about rates of change, okay, we are talking of derivative of that thing, okay, in terms or with respect to time. Okay? And you already know that when we say dy over dx, it is represented by the rate of change of y with respect to x. But this time, we are not doing that. We are actually doing rates of change. Therefore, we are considering the time that we have in the problem. Just take a look at this example. Variables v and t are connected by the equation v is equal to 5t squared minus 8t plus 3, considering that t is time. Okay? Find the rate of change of v with respect to t when t is equal to 4. Okay? So basically, it will be dv over dt. Okay? And remember, when we've learned dy over dx or differentiation, in order for us to find out the rate of change of this dv over dt, okay, and rate of change, when you study further the definition of gradient, gradient itself is a ratio. Okay? A ratio of the changes of x and y. Okay? But it is in a ratio, rate of the change in y over the change in x. Thus, what we are going to do here is get the derivative of 5t squared minus 8t plus 3, which is 10t squared, 10t, minus 8, okay, and put in the value of that t, which is 4. So 10 times 4 minus 8. Thus, the rate of change in terms, the rate of change of v with respect to t is 40 minus 8 is 32. As easy as that. Okay? Now, what if I have an example like this? Okay, I already erased that. Okay, now let's move on to the next example. Variables x and y are connected by the equation y is equal to x cubed minus 5x squared plus 15. Given that x increases at a rate of 0.1 units per second, find the rate of change of y when x is equal to 4. Okay, you notice that it says units per second. So it means, okay, x increases at that rate. in terms of seconds. What is second? It's basically time. Therefore, x increases, or there is change in x with respect to the time. What does that mean? It means dx over dt. Okay? Basically, if you read this and analyze this, it means the derivative of x, or the change in x with respect to time. Remember, rates of change basically tells you that there is time, okay, that is happening, or that is being consumed. Okay? So therefore, dx over dt is 0.1. Okay? Next. And also, you know that x is equal to 4. Now, the question is, you have to find out the rate of change of y. When you say rate of change again, it's always with respect to the time. Thus, if you look for the rate of change of y, okay, it should be dy over dt. Because rate of change of y in terms of x. Okay? Or with respect to x. So it will be equal to what you are looking for. That is basically what you are looking for. So, okay, to look for this, I need to do a little bit of algebra. Okay, dy over dt can be taken by multiplying dy over dx. Why do I need to multiply dy over dx and dx over dt? Okay, so let's just put a dot. Anyway, it also means multiply. Okay, dy over dx times dx over dt. Why? You will be asking me, Mr. Mars, can I get dy over dt by this? Of course, yes. By, okay, you see dy over dx times dx over dt. What is dx divided by dx? It's basically 1. So I can just, okay, scrap that out. If ever, what will be left is dy over dt. Okay? But it's not as simple as that, because you need to find out dy over dx by getting the derivative of this, or differentiating this one, multiplied by dx over dt, which is 0.1. When you find out the derivative of y in terms of x, you change the value of x with 4. Okay, before multiplying it with 1. So the first thing that you need to do is get the derivative of y in terms of x, which is 3x squared minus 10x, okay, minus 10x, plus 0, plus nothing, okay, nothing already. So, as I've told you a while ago, you just basically need to change the x with 4. So, it will become 3 times 4 squared minus 10 times 4. Okay? Thus, it will give you 16 times 3 is 48, minus 40 is 8. So, I have now dy over dx is 8. Okay? Next, since you know that dy over dx is 8 and dx over dt is 0.1, dy over dt is now equivalent to 8 times 0.1. What is 8 times 0.1? It is equivalent to 0.8. This is now the rate of change of y when x is equal to 4. Of course, it will give you another answer if the value of the x is different. Okay? I hope you have learned something today. Very basic things. Rates of change always talks about time. So, in your past year papers, if there is no time that is included in the question, then it's not about rates of change. Thank you and God bless. Please don't forget to like, comment, share, and subscribe, and click that bell button to be updated with our new lessons.